Okay, good afternoon. Oh, wait, is this working?
Hello.
Oh, it is working. Okay. If the mic doesn't work, then it doesn't record properly. The audio doesn't record. Okay, so we were talking about conditions at the end of the last lecture. So just to quickly review, right? And or are the same in Java as they are in C, right? And has higher precedence, right? So anything, if you have a conditional expression, right, where there are multiple ands and ors, right, then the parts with the ands happen first, right, or evaluated first, right? So you have an and here, got an or here, right? So the and, because it has higher precedence than the or, causes that expression to be evaluated, that expression to be evaluated, and then the and of those two expressions to be evaluated before the or is evaluated. Right? So what this line here is saying is if the year is evenly divisible by 4 and not evenly divisible by 100. Right? So the percent operator, if you remember, hopefully you were taught it's the remainder operator. Right? So do the division and compute the remainder. Right? So take the year divided by 4 if the remainder is 0, then that's true. Right? Take the year divided by 100 if the remainder is not 0, so it's not evenly divisible by 100. Right, then that's true. Right? So apparently a year is a leap year if the year is evenly divisible by 400, or if the year is evenly divisible by 4 but not evenly divisible by 100, right? Which is the technical definition of a leap year. Right? So if that condition is true, I'm going to return true. Right? If that condition is false, I'm going to return false. Right? Now, some people will argue that if you've got an expression like this, you should probably put parentheses in order to clearly indicate the precedence of the operators. Right? So you can if you want to. Right? So parentheses always have highest precedence in most programming languages that do math. Right? So if you put the parentheses in, then that indicates that this is definitely going to happen. The part inside the parentheses will definitely happen first. Right? And then the or will happen with this expression here. Right? But there's what you really should do in this statement here is you should recognize that this is a condition of some kind, right? So it's true or false, right? So really what I'm saying here is if this stuff is all true, I'm going to return true, right? Otherwise, I'm going to return false, right? So really what I'm saying is I can just compute what the value of that is and return that value, right? I don't need the if statement here. I can just do that. Right? So I can just return the result of the logical condition. Right? And this is the way you probably should write it eventually. Right? You can write it like this if you want to in this course. I'm not going to deduct marks or anything from you. Right? But if you continue with programming in your future, right, whether professionally or not, right, you should start to train yourself that, hey, this is just the result of a logical expression. I don't need the if statement to return that answer. Right? Just return the result of the expression. And so you should start to train yourself to write that instead. Right? It's very funny when you read code that says if something equals true, return true. Right? Or if something equals false, return false. Right? You can just return the something. Okay, if you need to negate something, that's the exclamation mark, but I'm pretty sure you know that. Right? So if I want to, I can call is leap year with some year. Right? That returns true or false. Right? The exclamation mark negates the result. So this says if a year is not a leap year, right, return 28. Right? So the number of days in February. Right? 28 days if it's not a leap year, otherwise return 29. Right? So if you need to negate a logical expression, it's just the exclamation mark. All right. I think most of you should, or you should all know that, or have at least seen something like that before in your previous courses. Okay, so this is the lecture that you should have for the lab. Right? So obviously the people who wrote the lab 2 hours ago didn't have this lecture, so I had to give them a little quick primer. But the intent of lab 1 is that you actually have this lecture before you get to the lab. Okay, so arrays in C and Java are similar. Java arrays are slightly easier to use. They're safer to use for sure. Right? Now, arrays in Java are somewhat uncommon, unless you're doing a lot of arithmetic. because the Java standard library has different types of collections that are a lot more flexible than arrays. Right? Arrays are kind of awkward, right? You know, they have a fixed size, right? I can't change the size of the array because it's fixed, right? They always contain the same number of objects. If I want to add more things than there's space in the array, I have to make a new array. I have to copy the old array into the new array, and so on and so forth, right? That's awkward for a lot of cases, for a lot of use cases, right? And so in Java, most Java programmers tend not to use arrays, unless they're doing something involving science or math, right? Lots of computation, which is what you're going to do on Lab 1. OK, so in Java, an array is a container. It's just a container that holds a fixed number of values of a single type, right? Same as in C. Like in C, when you create the array object, you end up setting the length of the array. Right. OK, so when you declare an array variable, it's slightly different in Java than it is in C. Right? So in C, you would write double collection square bracket, right? And that would make a variable that could store an array object. Right? In Java, the square brackets go on the type instead. Right? So double square bracket collection. Right? That makes a variable called collection. Now in Java, that variable can store a reference to an array of double values. Right? That's what that means here. Right? That stuff right there. So I can make an array and then store it in collection. Right? So that's what that means. In C, you can't do that. Right? If I make an array variable, you cannot reassign to the array variable, whether they taught you that or not. Right? If you have a pointer, it's different. You can always assign to a pointer. If you make a variable, an array variable in C, you cannot assign another array to that variable. In Java, you can. Right? So that makes the variable. It doesn't make the array. Right? There's no array here. Right? There's just a variable called collection. If you try to use collection as though it were an array, you'll end up with an error of some kind. Right? Because there is no array object yet. OK, just like in C, if you happen to know how big your array is and what you want to have in the array, you can use an initialization list. Right? So squiggly bracket or brace, and then the values that you want to store in the array as a comma-separated list. Right? So you're allowed to do that in C as well. This works. So this here makes an array variable called T. Right? It's an array of car, so it can hold cars. Right? This makes an array of length 4 and sets the elements to A, B, C, and D, right? So element 0 is A, element 1 is B, element 2 is C, element 3 is D. Right? So that's fine. You cannot use this notation for assignment. Right? This is initialization. Make the variable, give it a value. So that's called initialization. Here, I've got the variable. Right? I haven't given it a value yet. On the next line, I try to do assignment. Right? So this is assignment, right? Variable equals something, or existing variable equals something. That's assignment. Right? This is also true in C. Right? I cannot use that initialization list for assignment. Right? So that doesn't work. Also doesn't work in C, because you can't assign to an array in C. So that doesn't work. You can only do initialization. You can only use the braces for initialization. OK, so how do I make an array then? So normally, when you make an array, you know how big the array is, or at least you know the starting size of the array. Right? You probably don't know what you want to put in it. So what you want to do is you want to make an empty, well, quote-unquote empty array. Right? And so the way you do that in Java is with this new operator. And you specify the capacity or the length of the array. Right? So the capacity is just the maximum number of elements that the array can hold. Right? And you specify the capacity in square brackets. So here's my variable collection. Right? There's no array yet. Right? It's just a variable. When I write collection equals new double square bracket 10, now there's an array. Right? So now collection refers to an array. It refers to an array of 10 double values. Right? So now I have an array. Now I can use collection as though it were an actual array. OK, if you make an array of primitive type, right? So int, double, float, whatever, long, Boolean, right? Then the array will have all of its elements set to a default value, right? Which doesn't happen in C, right? If you malloc something in C, whatever you get back is just random garbage, right? Your array elements could be anything. In Java, they're set to well-defined values. So I'm just going to take the, so instead of just showing you this code, I'm actually going to open Eclipse, and I'm going to show you how to make a class with a main method, and then run this in Eclipse, right? So let's do that now very quickly. And that way I don't have to write all of this out in the lab. Where's Eclipse? Here. Boop. Okay, it might be hard for you to read because the UI font I can't easily change, right? So the stuff over here and in the title and in the menus, it's probably hard for you to read at the back, right? Now normally this panel over here, you're not going to see all of that stuff, right? I have lots of stuff in this panel here. This is called the Package Explorer, right? So over here, I've got my 124 lectures, which I'm just going to recycle here because I'm too lazy to make a new project, right? Somewhere I've got a folder. So here, so normally you see that. If I double click on that, that will open up the project, and it'll show me this folder called SRC, source, right? So this is where all your Java files are going to go. Here it looks like a folder called default package. This is where all your classes go if you don't put them in what's called a named package. I'll tell you what packages in a little bit, right? So I'm just going to stick it here for today. So I want to make a new class here for today's lecture, right? So I'm going to make a class. So on the default package, you can just right-click, go to new. Oh, sorry. What did I just do? Uh-oh. How do I go back? Did that work? OK, there we go. OK. OK, so on default package, right-click, new, class. Alternatively, right, with the default package selected, just go up to your file menu, and then do new, new, and then class. Right? And then when you do that, this window will pop up. And then you can fill in the contents of the window. Right? So here it says, where do you want to store the file? You should generally leave that unchanged. Right? The next line is for the package name. We'll talk about that later on. But here's the class name. So now I want to give my class a name. Right? Should begin with a capital letter. Today is lecture 3, so let's call it lecture 3. Even though, well, I think the lecture slide says 4, so let's do lecture 4. Right? If you want your class to have a main method, click that box right there. And in Java, the Eclipse will stick it in for you. Right? So it says public static void main. Right? If you want your class to have a main method, check the box and click finish. And voila, there's class lecture 4 with an empty main method. Right? And so now we're ready to go. So I'm just going to copy and paste the code from the lecture slide. Right? So I'm just going to take, back up. I'm going to take this and cross my fingers and hope this works. When you copy and paste from PowerPoint, you don't always get what you think you're going to get. So PowerPoint likes to insert a funny type of space character. So this doesn't, never mind. This doesn't always give you what you want. OK, so Control copy. There we go. Control V. OK, so this looks like it worked fine for me today. Oh, did it? No, it didn't. OK, so there we go. Right, so there's the contents of that slide. If you ever see anything in red or orange in Eclipse, something's wrong. Right? So it might be hard for you to see, but you can see here arrays is underlined in red, and there's a little red X over here. Right? So if I hover over that, right, you get this little window here. It says arrays cannot be resolved. So in other words, it's complaining. Right? It's saying, I don't know what this class called arrays is. Right? And so why doesn't it know? Because I didn't import it. Right? One of the fixes, or one of the suggested fixes, happens to be import arrays, right? From the package called Java util. Turns out that's what I want. So I'm going to click on that, and Eclipse fixes it for you. Right? So inserts that in for you. And now the error has gone away here, which is nice. Right? I can save that. So as soon as you edit the file, save, right, before you run it. So Control S or Command S if you're on a Mac, right? Or again, File menu, or there's a little disk up here. Up here, there's a little save button that you can use, right? They all work, right? And now you can run your program. So there's a little green button up here, right there, right? There's a little run button at the top. It's just a little play button. You just click it, and the program will run, and the output, if any, appears below it, right? Or to the side. It depends on how if you've moved windows around or not in Eclipse, right? OK, so let's see what it printed out. OK, so here I made an array of 3 Boolean values. Right? Here's where I printed it out. I'll explain how I printed it out in a second. Right? So when I print it out, I get false, false, false. 3 Boolean. So it looks like when you make an array of Boolean, Java automatically sets all the values to false. Right? here's an array of 4 int, right? And when I print that out, I get 0, 0, 0, 0, right? So when you make an array of int, Java fills in the values with all zeros. And here's an array of 5 doubles, right? So when I print that out, I get 0.05 times, right? So Java sets the contents of an array of double to 0.0, right? So all the numeric values get, all the numeric types, their values get set to 0. Boolean gets set to false, right? Now, when I print it out, I do something a little bit odd, right? So normally you would think I can just use system.out println, right? So I could just write I can just write system.out.print or print line, right? And then the name of the variable, right? So let's try that, some bools, right? And you say, well, that ought to work, because it seems to work so far anyway, right? Everything I've done so far, you can print out numbers, I can print out strings, everything seems to work. It turns out it doesn't work with arrays, right? So let's see what happens when I run this now. So I've edited my code, I save my code, I run my code, right? And I get some strange number down here, right? So apparently that's what my array is, right? Z at 626B2D4A, whatever the heck that means, right? You get some gibberish, right? So you probably don't want the gibberish, right? That's actually encoding a memory address of where that array is in memory. But I can't access memory anyway, so it doesn't mean anything, right? So that's the stuff you get out, right? And it happens because Java doesn't know how to natively turn an array to a string, right? And println always needs a string. So what you have to do is you have to call some method that can take an array and convert the contents to a string, right? And that's what this arrays method does right here, right? So arrays.toString takes an input array and computes the string representation of that array, right? So what it does is it puts a square bracket in, right? The first element gets converted to a string, so it's false, so it gets converted to the string false. Then you get a comma and a space. Second element converted to a string, comma and a space, right? Third element converted to a string, and then the closing square bracket, right? So it's pretty easy to print an array. You just have to remember you have to call arrays2string. And it's much easier than printing a C-style array, right? With a C-style array, you have to write your own loop. I have to use printf. I have to know what the element type is, and I have to use the right conversion, and so on and so on and so forth. If I want to get the opening and closing square bracket and the comma and a space between everything, now it becomes even harder, right? So slightly more complicated than printing out most stuff in Java, but not too bad. Right. Any questions so far? All right. So there's the default values for arrays. It's pretty easy to remember. Everything's 0 unless it's Boolean. If it's Boolean, it's false. Right. OK, so sometimes you don't want all zeros or all falses. You want something else. If you want your array to contain a bunch of duplicated values, all the same, just use arrays.fill. Right? So arrays.fill will take an array right here. Right? So it'll take an array some doubles, and it will set all the values to whatever you want. Right? So here I'm going to set them all to 1. Right? I guess while I have Eclipse up, we can run this too. Right? So let me just grab this and this. Right? So I'm going to copy that. And I'm going to paste it into here. So I'm just going to change this line right here. Right? That's all I'm going to do. So I'm just going to change that to that. Right? There we go. Let me get rid of this line here. I don't need that. Right, there we go. OK. So now I'm going to print out some doubles first, right, after I filled it. So when I run that, I get an array of 10 ones. Right? So that's how fill works. So if you actually go and take the time to poke around inside this arrays class, and you can find the documentation for this class quite easily. Again, I'll show you how to read the documentation for the classes later on. You'll find that there's a whole bunch of methods that operate on arrays. Right? So if there's something you need to do with an array, it's possible that there's already a method implemented for you that does it. All right, so what about the length of an array? Right? So in C, if you write a function that takes an array, you have to pass the size of the array to the function. because C doesn't keep track of how big an array is. That's not true in Java. Right? In Java, an array knows how big it is, which is much nicer than in C. Right? So here, when I make my array of 10 doubles, right, and I store a reference to that array in collection, right, I can use the variable collection and write dot length to get the size of the array. Right? So collection dot length, in this case, will be 10, and it's always an int in Java. Right? So it's always an int. You can't assign to collection dot length. Right? I can't write collection dot length equals 5. That won't work. The compiler will complain. Right? But the length of the array is always known to the array, so that's nice. Just like in C, you access the array elements using a zero-based index. Right? So first element over here, right? That's index 0. Second element's 1. Last element in this case is 9. Right? Array length is 10, so the last valid index is 9. Right? So the last valid index for an array in C is always the length of the array minus 1. Right? First valid index is always 0. Right? So for example, if I have my array of 10 values, right, then just like in C, right, I can set the first element to 100, right, using the index 0. I can ask for the first value, right, again using index 0. I can set the second element using index 1, and so on and so on and so forth, right, up to the last element, right. So the element at index 9, that's fine. Now, what happens in C if you use the index 10? Right? So the answer is you don't know. It might work, or it might appear to work. Right? Your program might crash, or something else could happen. Right? That's what happens in C. So in C, the language specifically says the behavior is undefined if you try to access an element that's using an invalid index. Right? Which sucks. Right? It's very hard to debug a C program. Right? In Java, that doesn't happen. If you write collection 10 here, your program immediately crashes, and Java will tell you, the Java runtime will tell you you've used an illegal index. Right? It'll even tell you the line on where it happened. Right? So you can go back into your code and trace to the point where it happened. Right? So you'll get what's called an array index out of bounds exception, right? Which is a mouthful, but it's very descriptive. Right? And your program will stop. So that's nice. Right? So Java has built-in array bounds checking. Which is much nicer than C. Okay, so unlike C, attempting to access an element in an array using an invalid index immediately causes an error. Right? Errors in, the other thing in C is there's no well-defined mechanism for a function to tell the user that something wrong has happened. Right? There's no one way to do it. There's lots of different ways to do it. They all suck. Right? In C. In Java, there is a standard way to do it. Right? So in Java, if a function encounters an error, or if whoever implemented the function has some logic that can detect an error condition has happened, you can throw an exception. Right? So an exception is just a special kind of object that's created when an exceptional event occurs. Right? That object can contain information in it about why the event occurred, which is useful when you're debugging your program. Right? Back here, you get an array index out of bounds exception, and you also get the line number in which it happened. Right? You don't get the index. You don't get the value that was used, unfortunately. But at least you get where it happened, which is nice. Right? So when an exception occurs, the program stops running at the point where the exception occurred. Right? And then in Java, complicated stuff happens. Right? So you can ignore this for now. Right? Right? So for now, if your program encounters an exception, it will stop running. Right? It'll crash. All right, so whenever you have an array in C, it's going to be extremely common that you write a loop involving the array. Right? I want to do something with each element of the array, or something with every second element of the array, whatever. Right? So if I want to find the maximum value in an array in C, you could write the following function. Right? So maxilem returns the largest element in that array. Right? That array apparently has that size. Right? If you haven't seen the type size underscore t, that's the standard C type for indicating some things like indexes. If you don't know what it is, it's just some sort of unsigned int. Right? That's all it is. So it's always guaranteed to be 0 or bigger. Right? Now that's an array of double, so the maximum element must also have type double, right? So if I call this function, I have no control over what the user passes in for the size, right? All that I know is that it's going to be 0 or bigger. So if they tell me the size is 0, I can't actually find the maximum element in an array of size 0. There are no elements in the array, right? So this is an error of some kind. It's not clear what you do in C, right? I don't know if they told you how to deal with this in C or what you would do, but something has to happen. Something should happen here, right? Okay, so let's assume that the size is not 0, right? So it's bigger than 0. So how do you find the maximum element in the array? Well, you start by saying the largest element is the first element, right? And now I look at all the other elements. I'm just going to change this very quickly. All right, I want to make that 1. Okay, all right, so I start by assuming the largest element's the first. Now I want to look at all the other elements, right? So the second element starts at 1, right? What are all the valid indexes? Well, up to the size of the array minus 1, right? So if I is going to be my array index, right, then it has to be less than size, right? Because someone's telling me that's how many elements are in the array, right? So I start at 1 because I've already looked at the first value here, right? Go up to but not including the size, right? So if array I is greater than high, I have a new highest value, right? So my new highest value is just the ith element, right? Look at all the values in the array. When you're done looking at all the values, you know the highest value. You just return high, right? Okay, so I can do the exact same thing in C, in Java, right? The code is literally almost exactly the same, right? So up here, I don't need the size of the array. Why? Because the array knows how big it is, right? So to get the length of the array, I can just use array.length right there, right? I don't need the size. What else? Okay, here. So if the length of the array is 0, well, now I have a way, right? In Java, I have a way to indicate that there's an error, right? So the way to indicate that there's an error is to, we say, throw an exception, right? So an exception is just an object, right? So in in Java, when you make an object, there's always this new operator involved, right? So when I made an array, there was a new operator, right? Because arrays are also objects in Java. So new illegal argument exception. So this is going to make an object of type illegal argument exception, whatever that is, right? If I want to, I can give a little error message, right? So that's the error message that will be printed out if this exception is thrown, right? So now whoever calls the method incorrectly knows, hey, you can't, the array length was 0 and you can't do that, right? And then the keyword throw to actually throw the object, right? So it's always throw new some type of exception name and then some type of message, right? And so if the array length is 0, we'll throw an exception. The method stops running here, right? So it does not go past this line here if the exception is thrown, right? And now the caller of the method, they have the option of whether or not they want to deal with the exception. If they don't deal with it, the program crashes, right? Now the rest of the code is the same, right? Start out with a variable called high, assume the highest element is the first element, and then process the rest of the elements, right? Again, you can start at 1 here instead of starting at 0. It's not wrong to start at 0. It's just you end up processing the first element twice, right? Just like in C, right? That I, because I declared int I inside the round brackets, the scope of I is the body of the loop, right? I can't use I right here, right? If I need to use I here, I have to declare I before the loop, right? But if I declare it inside the round brackets, then I is only usable inside the loop. It's the exact same thing as in C. Now, Java has a second type of loop, which is convenient in cases like this, right? So this is the C-style loop, where you use a counter, right? Java has a for each loop, right? So this is the exact same code, this time using a Java for each loop, right? So if you have an array, or a list, or a set, or a map, and we'll learn about those later on, right? Then you can typically write a for each loop instead of using a counting style loop, right? So everything's the same, except for what's inside the round brackets on the for statement, right? And so the way to read this is, right, so round brackets, I'm going to make a variable called e, right? Its type is double, right? The reason it's double is because my array element type is double, right? So e is going to be my loop variable, right? In other words, it's usable inside the body of the loop, right? What's the value of e? Well, this colon ARR means, right, for each value e in the array ARR, right? So for each value e in ARR, right there in that box, right? I can do something with e, right? So the first time through the loop, e is the first element of ARR. Second time through the loop, e is the second element of ARR. Third time through the loop, e is the third element of ARR, right? So I don't need this counting style loop, and I don't need the counter. I don't need the square brackets to index the array element, right? I can just use the name e here, right? So if e is greater than high, then high must be equal to e, right? And then at the end, I can return high, right? So if you need to write a loop over an array, and I only need one element of the array at each iteration, then you can use a for each loop. All right, any questions? Okay, so a regular for loop, so this is the details of the regular for loop, right? I think you all should know this, right? A regular for loop has four main parts, right? The initialization expression, the termination condition, the update expression, and then the loop body, right? So, right there, initialization expression, right? Create a variable for the loop body, right? And give it an initial value, right? The first time the loop runs, I will be 0. Straightforward, right? Termination condition, that's the part in the middle, right? If that condition is true, the loop runs. If it's false, the loop doesn't run, right? The condition is checked before, each time before the loop runs, right? So before the loop runs the first time, that condition is checked, right? Is 0 less than the length of the array? If yes, the body of the loop runs, right? The update condition is there. The update expression, sorry, is there. Right? Typically in the update expression, you change the loop variable that you declared here, right? So typically that's I plus plus, or plus plus I, or I equals I plus 1, or I plus equals 1, however you want to write it, right? Of course, if you're jumping by more than one value each time, that looks different, right? So I equals I plus 2 will jump every second element, right? And then you have the loop body right there. Okay. If the body of the loop has to access more than one element of the array at a time, you have to use a counting style loop. It's easiest to use a counting style loop, right? So in other words, it's awkward to use a for each loop if I need to access more than one element of the array at the same time, right? So if I want to test is an array sorted or not, right? Then what I need to do is I need to look at the first element and the second element, right? Is the second element bigger than the first element? Right? If so, keep on going, right? Or is the second element smaller than the first element? If yes, then the array is not sorted in ascending order, right? So I need to compare two elements of the array on each iteration of the loop, right? So I'm going to start by assuming that the array is in fact sorted. So I'm going to set that to true, right? I'm going to start with an index of 1, but that's because I'm going to subtract 1 inside the loop body, right? So I'm going to start at 1, but I'm going to subtract 1 here, and I'm just going to use I here, right? So the first time through the loop, this will be array 0, and that'll be array 1, right? Second time through the loop, that'll be array 1, and that'll be array 2, right? Third time through the loop, array 2, array 3, right? So it's going to compare adjacent values in the array, right? If the previous value is bigger than the next value, the array is not sorted in ascending order, right? And so I can set is sorted to false. Right? And then at the end, I can return is sorted. Right? Again, this is another one of these methods where you really should check, right? Is the length of the array at least 1? If the array is the length of the array, is it 1 or 0? Right? So less than or equal to 1. Right? If it is, you should just return true right away. Right? So in other words, what you really should do here, it's going to look bad too because it's not going to have all the nice color coding, if array length is less than or equal to 1, return true. Sorry, return true, like that. I should also put that in a pair of parentheses, but this will work anyway. Right? So you really ought to do that. Right? Without that statement, that loop crashes. Right? So without this statement here, if I pass in an array of length 1 or 0, right, this loop dies. Right? So if the length of my array is 0, right, then there is no array element indexed 0, and there's no array element indexed 1. Right? So as soon as you try to access either of those elements, you get an index out of bounds exception. Right? If the length of your array is 1, there is no element ARR1. Right? So again, that loop crashes. Right? So one of the things you always have to watch out for when you're using arrays is that there's usually some sort of special condition that you have to take care of if the array is empty, or sometimes if its size is 1, or 2, or 3, right? Depending on the problem. Right. So this is what, if you were to draw this out as a picture, this is what the loop is doing. Right? On iteration 1, so this is on an array of length 16. Right? On iteration 1, I minus 1 is 0, right? I is 1. Compare those two elements. Right? Is 12 greater than 13? No. So the loop continues. Right? 13 greater than 14? No. Loop continues, and so on, right? Up to there. All right. If you know about break, you can break out of this loop. Right? Because as soon as I know that that this array is not sorted, I'm done. Right? I don't have to look at everything else. Right? And so if you need to break out of a loop, the statement is break, same as in C. Right? And so as soon as I find an element or a pair of elements that are not in sorted order, I can stop. Right? I don't have to process the rest of the array. So that's nice. Right? It's probably going to be a little bit faster on average. Right? So here is where the break where a break would stop running the loop. Right? When I get to iteration 3, right? I minus 1 is 2. Right? I is 3. Is 99 greater than 15? The answer is yes. Right? So I know the array is not sorted, and I can break out of that loop. Right? What you cannot do in this loop here is sorted. Right? So you see, so I see this a lot in 124 and in this course here. Right? A lot of students will write this loop, and they'll try to return true from inside this loop. Right? You can't return true from inside this loop, right? I don't know that the thing is sorted until I look at all the elements in the array, right? So in order to return true, the only way I can return true is if I actually look at everything in the array, right? The only place you can return true is down here, right? You cannot return true from inside this particular loop, right? So if you find yourself returning, when you find yourself returning true or false from inside of a loop, right, you have to ask yourself, does this actually make sense? Right? Can I really return this answer here? Like, or do I have to look at everything else? Right? So be a little bit careful about that. Instead of using a break statement here, you could also just return false here. Right? So here you just write return false, and that would also be fine. Here's another example of when I'm accessing more than one array element at a time. Because I'm accessing more than one element at a time, there's no good way to write this using a for each loop. Right? So here I got another counting style loop, right? So this one's going to check is, I want to reverse, the elements in an array, right? So the first element and the last, I want to switch those. Second element and the second last element, I want to switch those, right? Then the third element and the third last element, I want to switch those. Again, there should be some condition here where you check on the size of the array, right? I'm going to leave that out for now, mostly because it doesn't fit on the slide. Right? So the index at the back of the array, that's going to be j. Right? The index at the front of the array, that's going to be I. Right? So j is going to start at the last element of the array. I is going to start at the first element of the array. Right? And now I'm going to swap ai and aj. Right? So they taught you how to swap, right? At some point, they taught you how to swap two variables. Right? You need a third variable, right, if you want to swap. So I need a third variable, and I have to remember one of the two swapped values. Right? So I need int temp equals ai, or aj, it doesn't matter. if I'm going to remember AI, I can now change AI. Right? So AI now becomes AJ. Right? And AJ becomes the old AI, which is temp. Right? So introduce the third variable, swap your two values, and then continue. Oh, here, j minus minus. Right? So remember, j is the index of the element at the back of the list, of the array, which I want to switch. Right? So it starts at the end. Each time I go through the loop, I have to move j to the front of the array. Right? I is moving to the back towards the end of the array. J is moving forwards. Right? So j minus minus right there. Right? I gets updated up here. Right? So I and j, so here's I and here's j, they just move this way like that. I think there's a picture. Yeah, here there is. Right? So on iteration 1, I'm going to swap that element and that element, right? I and j. So I switch them, right? And then the next iteration, I goes up by 1, j goes down by 1, right? I switch those two values, right? I goes up by 1, j goes down by 1, switch those two values. Eventually you get to here, right? So I is 7, j is 8, right? I switch those two values. I switch those two values, right? Now on the next update, right, I goes up by 1, so it's 8. J goes down by 1, so it's 7. Right? So the loop condition is no longer true. Right? I is no longer in front of j. Right? They've passed each other, and so now the loop can stop. Right? If you keep going, you unreverse the list. Right? So if you keep on going, you end up swapping all the elements again, and your array ends up looking the same as what it started as. Right? So that loop condition there is a little bit different than many of the loop conditions you've probably seen before in the past. Okay. Now, in that example, I had I and j, right? Both int. Right? So it turns out that you can, sorry, you are allowed, if you have two loop variables, right, you're allowed to make them here. Right? So I can actually declare 2 or 3 or n loop variables in the initialization part here. Right? I can then use those variables in the condition and in the update. Right? The only constraint is that they have to have the same type. So I can only use 2 ints or 3 ints or 4 ints. Right? So because in this case, I and j are both ints, I can write this. Right? So I is 0, comma, comma, j is equal to the length minus 1. Right? I is less than j. Here I can update them both. Right? So increase I by 1, comma, decrease j by 1. Right? So that's fine. If you happen to have two loop variables of the same type, you can declare them all in the same place and use them inside the for the termination condition and for the update expression. Right? But they have to have the same type. You can do this in C as well. Right? What's this one doing? Oh, okay. One more time. Right? So again, if you are trying to, if you're accessing elements from 2 or more arrays, right, 2 different arrays, now you can't use a for each loop. Right? A for each loop can only access the elements of one array at a time. Right? So if I want to access the elements of 2, in this case 3 different arrays, right, I need to use a counting style loop, right, the C style loop. So this array here, this method here, takes the elements in A and sums them with the elements in B. Right? This is just vector addition. Right? So can I add 2 vectors? Yes, as long as they have the same length. Right? So if the length of A and B are different, throw an exception. Right? Okay, I want to make a new array to store the sum. In Java, that's easy. Right? Make a new array. Right? What's its length? Well, it's just the length of A or the length of B. Doesn't matter. Right? Write your loop. Inside the loop, right, just sum the elements of sum the elements AI and BI and store them in CI, and away you go. Right? So that's vector addition in Java. You would do, again, you'd do something similar in C. Right? You need a malloc here. You'd have to return a pointer up here, et cetera, et cetera, et cetera. Right? Oh, yes. Do I want to talk about this? Sure, why not? So there's this other language you may have heard of called Python. Right? Which is what the 124 students, they take their previous courses in Python. So Python's got what looks like a list. Sorry, what looks like an array, right? But in Python, you can slice that array or slice that list to get part of the list, which is super handy, right? So I can write this funny thing, 2:5. Right? So what that means is there's element 0, there's element 1, there's element 2, right? So I'm going to take element 2, element 3, and element 4, but not element 5, right? So I'm going to take the 12, 13, and 14. I'm going to take that part of the list and return that back as a new list, right? So slice, in this case, is the list T2, T3, T4, which is super handy, right? Being able to pull out part of an array or part of a list and do something with that sub-array. You can't do that in Java or C, right? So Java doesn't have a built-in slice operator. C doesn't have a built-in slice function, right, or an operator. But you can always write your own method to do this, right? So if you wanted to write your own method to do this, it's not very hard, right? I will have an array. Oh, sorry, here. I want to slice it, right? So I want to slice starting at that index there, stopping at that index -1, right? So stop is always one past the element you actually want as your last element, right? So this is an array of int. So my slice is also going to be an array of int, right? And now I should check for some error conditions, right? So it must be the case that start has to be less than or equal to stop. Is that true? Start has to be, I think start has to be strictly, yeah, less than or equal to, I think. Right? So if start is greater than stop, that's a problem, right? I don't know how to slice from 5 to 2, for example, right? So there I just throw an exception. There's a bunch of other errors you have to check for here, right? So it's not sufficient just to check is start greater than stop, right? There's a bunch of other problems you have to check for, right? I have to check that start is actually a valid index for that, right? So I have to check that start is greater than or equal to 0 and strictly less than the length of the array. Right? For stop, I have to check that it's either a valid index or it's equal to the length of the array. Right? So I have to check is stop greater than or equal to 0 and less than or equal to the length of the array. Because remember, stop is always one past the last element. Right? So there's a bunch of other conditions I have to check for. Once I've checked for them, though, the rest of the problem is easy to solve. Right? So how long is my sliced array? Well, it's just stop minus start. Right? So make my new array of that length. And now just write a little loop and copy the sliced elements into the new array. Right? You have to do a little bit of arithmetic here, right, in order to write into slice properly. But otherwise, it's fairly straightforward. Right? If you want to use it if you want to call it, right, it's pretty easy to call. Right? It's just slice, pass in the array, pass in your start index, pass in the stop index, and you get your slice. Right? So this will also give you back the array 12, 13, and 14. All right, I think that's sufficient for today. And so you have more than you need for the lab next week. You may have heard from your colleagues in the lab that I accidentally gave you the solution for the last part of the lab, which is what happened. So I think I'm just going to give you guys the solution for the last part of the lab as well. So the lab will be a little bit short this week, but otherwise it'll be slightly different than the one they wrote, right? The pre-lab part's still the same. So if you've read the pre-lab already, you're good to go.